Welcome to the CCIP Bootcamp. Today we're learning how to use CCIP from Chainlink. First, we can look the transporter. It's a implement by Chainlink. The CCIP is a crossing chain implement. So we have a source chain. We can choose like Avalanche Fuji. We have a destination chain. We can choose Ethereum Sepolia. And we can transfer token and message. Token we can choose like USDC or CCIP, BNM. Here, I want to transfer one. Here is a button. We have two ways to pay the fee to transfer. One is native token. On the Avalanche Fuji, it's Aave. Or we can pay use Chainlink link. It's more cheaper. Now we can approve USDC because the contract need to approve. They can get this balance from our wallet. Here is two ways to approve. One is approve one time only, another is approve unlimited amount. We strongly suggest this one because it's more safe. The contract most get 1 USDC from your wallet. Our MetaMask pop up and next approve. Wait a minute. Here is time about 6 minutes. After approve USDC, we need approve link also, because the link is which we choose to pay the fee from this to this crossing chain. And it also has a two-way. We just choose safe way. Next, approve. So we need to wait 10 seconds or 20 seconds with the transaction confirmed. Now we can send the crossing chain transfer. Hit send. Metas pop up. Okay. Now we send 1 USDC from Avalanche Fuji testnet to the Sepolia testnet. So the transaction is confirming. Okay, we can view the transaction on the CCIP Chainlink Explorer. When the status turn successful, this transaction is confirmed, and on Ethereum Sepolia we can get this 1 USDC. Okay, so now we have a symbol. We get how to use the call function of Chainlink CCIP. After that, we can learn some concept of Chainlink CCIP. The first is interpretatory. Here, in this picture, we have two networks, because on transporter, this is Avalanche Forja testnet. This is Ethereum Sepolia testnet. Traditional cross-chain solution can just provide a centralized way, but on the Chainlink CCIP, we can get a decentralized way. So here we have an important concept line. Blockchain A to blockchain C. We can just use a line from A to C, and this line cannot support C to A. If we need C to A, we need another line. So this design has a great compatibility. We can expand the line in the future when more blockchain add to the network. So how can we send the CCIP Chainlink the crossing chain message? We have the message, sender, and receiver. Look at this picture. So the message can include data or tokens, data like AVIX, tokens like AVIX, data like hello world, this message. And we can transfer tokens, transfer data and token. The CCIP sender can be UA or any smart contract. This is a sender on the source blockchain. And the CCIP receiver can be UA or any smart contract which implement CCIP receiver. So here is some term to learn. In this picture, this is our source blockchain, and user, he can send message which include data or tokens to the destination blockchain. He can send this message to the router on the source blockchain, and the CCIP can progress this message, and the destination router can send the message to the end user. The CCIP program token transfer is not a simple solution. It can transfer any message, and the destination smart contract can use this message to execute some functions or any action. This is very flexible. The developer have three main way to interaction CCIP to token transfer. The first, we can get this burn and mint. Now, on the left is a avalanche Foggia. On the right is a Ethereum Sepolia. So we can, if we want to transfer AVIX, if we want to transfer USDC from Foggia to Sepolia, on this model, we need burn this, and on the destination chain, we need mint this. Okay. And if we want to transfer back, we need to burn USDC and mint USDC. The second mode is locked at the mint. On the source chain, we want to transfer USDC. We lock USDC and mint on the destination chain. If we want to transfer back, we need to burn the USDC and unlock the USDC on source chain smart contract. The third pattern is lock and unlock. Lock, unlock. If you want to transfer back, lock, unlock. So what's the difference between the three ways? They can also achievement crossing chain transfer, token transfer, but the first way need more control to the token, because if you can burn and mint a token, you can control the value of it. So, but this is more easy to achieve. Here is a simple traditional financial CCIP crossing chain and decentralized financial CCIP crossing chain. You can learn. Okay. Now we need to understand how to use Chainlink CCIP by code. The first, we provide three ways to achieve. Remix is fast but not product. We can use hard hat, which is based on JavaScript, or Foundry, which is based on Solidity. So in hard hat, we can use npm to install this package. If we want to send CCIP message, the source blockchain contract must call CCIP send function, which is defined in interface router client. So I need two params. One is destination, because this is on the source chain. So the source chain to destination, I need a destination chain selector. And the message, which include data or token. The CCIP message is from to any message Solidity struct. It includes receiver data, token amounts, fee token, and extra arcs. In the extract, we can give it a gas limit. On the default situation, it will be 200,000. And on the destination blockchain, we need receiver, the CCIP receiver, to receive message. So, on the source blockchain, we need iRouter client and EVM any message. On the destination blockchain, we need EVM message receiver and EVM message. Here is the first exercise. We can open it on the remix. First, we need to deploy this contract on the source blockchain. Okay. Here, we have compile this contract and we want to deploy it. We need to ask the router on the source blockchain. Here is Avalanche Forger and the link we pay for the CCIP transfer. Look, here we can find the lines on Forger text. So we can get the router address and link. After we deploy this contract, we should allow list destination chain. So Avalanche Forger testnet to Sepolia testnet. This is a destination chain selector. So we should give this function this paragraph. Now we have a sender on the Avalanche Forger, and we need a receiver on the destination blockchain also. Let's see, we can get the destination lines on Sepolia and get the router address and the link address. After that, we have a contract and we need a log list source chain, log destination chain, a log source chain. After that, we need a log list sender. So this is keep safe for our destination contract. We allow list sender. Now you want to get some passenger message. After that, we set same revert. This function can simulate process message field. On my GitHub I give the full code of this bootcamp. Day 1, exercise 1. So when I transfer CCIP BM and some text, hello world, from Fugia to Sepolia, and I set same revert, I get this field message. 1 represent the field, and we can revert the logged token. We can get field message. Here is mine, and we can retry field message. After that, the field, the 1 is to change to 0. So in this exercise 1, we have learned send message, receive and process message on the crossing chain, and retrieve the field message. Now here is some questions you can test your learning. On day 2, we will learn CCIP architecture and message progress. So, the step 1 and step 2, we have learned. We need to prepare data, Chainlink selector, gas limit, and send to the destination blockchain. The Chainlink CCIP has 3 decentralized Oracle network to achieve 5 levels, to achieve 5th crossing chain security level. Here is 1, 2, 3, 4. 1 is centralized, and 2 is a decentralized theater, and 1 network controlled by 1 company or people, and multiply networks. Chainlink has 3. How can it work? It uses Merkle tree to prove if this achieve consensus, the committing decentralized Oracle network make consensus, and it will executing decentralized Oracle network. And here is a risk management network. The 3, the 5th security. So exercise 2, we need to create our first crossing chain NFT. We want to create a NFT on Arbitrum Sepolia and transfer it to cross-chain, transfer it to Ethereum Sepolia. Here is the code. First, we need to deploy the FT contract on the source chain and then we need to deploy it on the destination chain. And we need to enable chain. If we want to transfer from Arbitrum to Ethereum Sepolia, we need this enable chain Arbitrum. You can check the code on GitHub. After this prepare, we need to mint an NFT. Token ID should be 0 because this is the first NFT we provide on the Arbitrum. And we get this NFT. Now we can cross-chain transfer. We use the link to pay this cross-chain transfer. The token ID was 0, and from our wallet to our wallet. It's not conflict because this is on the source chain. This is on the destination chain. After that, we can check the transaction hash on the Chainlink CCIP Explorer. When the status turns to successful, we can get a NFT on here. So we did it. Mint an NFT on Arbitrum and transfer it to Sepolia. Use CCIP. Okay. If you achieve this, you will wait a long time because cross-chain transfer have many messages to process. If we want to get a more effective develop, we need this Chainlink local. It has 2000 design. Use Chainlink CCIP. The Chainlink local have two patterns. One is local pattern and one is fork pattern. Here is a different. Local pattern use localhost. Fork pattern use forkhost. Use focal network. And on the access tool, we actually transfer an NFT on the real network, but we can test it on the localhost by Chainlink local. If we use Foundry, we can install Chainlink local, or we can use npm install on the hard hat remapping. Okay. Here. That's 3 test. Okay, here we import CCIP local simulator fork and we use it. Get network details. This is a way to use Chainlink CCIP fork. This is crossing chain. Send USDC. We can send any token, NFT or USDC. This is our homework. How can we estimate CCIP receiver function? Use some gas limit. Oh, here is the day 2 homework. CCIP, use CCIP local simulator. Based on this project, homework 2. You can register a DOM on the source chain and look up the domain on the destination chain. In this homework, we need to use CCIP local simulator. Look this, CCIP local simulator configuration. We can get all of we need to simulate CCIP crossing chain. We have Chainlink selector, source router, destination router, and link token. You need to complete this by yourself. Okay. This is same with before. The first, we need to deploy it on the source chain, and we need to allow destination chain, and we need found the contract with link because we need to pay for it, and we need to approve. Remember the transporter, approve. After that, we need to send crossing chain transfer USDC, and when the status change to success, we can get this USDC, 1 USDC on the destination chain. Okay. This homework teaches us how to get the CCIP receiver gas limit. Look like this. Okay. Here is the result of this text. So, here the sender contract, send message, pay link, Chainlink selector, receiver, gas limit, and we can get the gas used by message executed. The result has 3 bunch. The first was 0, just 1, and 15, and 100. This is represent the low gas limit, the average gas limit, and the higher gas limit. So the homework asks we add 10% of the gas used to make sure that the crossing chain transfer works successful. What's the next? You can attend our SmartCon on this month. at the end of this month, 4 days. The first 2 days is hackers. You can get a certification from the Chainlink. And the last 2 days is SmartCon. You can learn more about traditional financial and decentralized financial. So, congratulations. You complete this lesson. Goodbye. Nice to meet you.